All right. Hi, everyone. Happy Tuesday. Miss Shaw here. And today we are going to continue on with talking about how to simplify sums and differences of radical expressions, and then also how to simplify the products of them. So when we use multiplication. Okay. Now, yesterday, we did go through and we talked about how if we're adding and subtracting, we need to make sure that they have the same number under the radical called the radicand. And when we're multiplying, we just have to make sure that they're the same type of root. So square root or cubed root. And really for today, we're just going to talk about the square root. Okay. So let's go ahead and let's begin. This Edpuzzle is going to take us through the first 2 pages of this assignment. And then this last page where it says try these on your own is your homework for tonight. So let's go ahead and let's begin. If we take a look at number 1, we have the square root of 10 times the quantity, the square root of 6 plus 3. So because we're dealing with multiplication here, we are going to distribute and use the distributive property to distribute the square root of 10 to everything. So the square root of 10 times the square root of 6 is the square root of 60. Okay, 6 times 10 is 60. They're both under the square root sign, so we'll leave it there. Plus 3 times the square root of 10 does need to be rewritten as 3 root 10 because 3 is not a radical and the square root of 10 is, so we cannot combine those two. Okay? Now, when we're adding these, it is really important that we make sure that if we can simplify them, we should. So for instance, the number 60 can be divided up into factors. And our goal is to be able to divide them into factors that give us perfect squares. So for instance, we can take 60, the number 60, because you can't really split up 10. The square root of 10 is just 10. So we can take 60, we can divide it by 4. Okay, we get 4 and 15. The next one would be 9. No. The next one would be 16. No. 25. No. 36. No. And so really that's about it, I think. So we can go ahead and we can change 60 into the square root of 4 times 15 plus 3 root 10, right? Because we didn't touch anything. The square root of 4 times the square root of 15 can be broken up. And this can be rewritten as 2 root 15 plus 3 root 10. And actually, that is in its simplest form. There is nothing that we can combine in order to make that work. So this is it in its simplest form. Okay. Same thing with number 2. We have the square root of 2 times the square root of 6 plus 5. So we can distribute the square root of 2 to everything on the inside. 2 times 6 is 12. So this turns into the square root of 12 plus 5 root 2. Okay. So the square root of 12 can be broken up into the square root of 4 times 3 plus 5 root 2. This can be rewritten as the square root of 2 times the square root of 3. I'm sorry, not the square root of 2, just 2, right? The square root of 4. Square root of 4 times square root of 3 plus 5 root 2. This turns into 2 root 3. And this that stays 5 root 2. And unfortunately, that is in its simplest term. We can't really do much else with that. Okay. So now let's take a look at the next one. Okay. We can distribute this square root of 3 to everything on the inside. Okay. 3 times 7 is 21. So this turns into the square root of 21 minus the square root of 12. Okay. Oh, I'm sorry. No, it does not, because guess what? the 4 does not have a radical sign, so this turns into negative 4 root 3, right? So now our job is to figure out, okay, what perfect squares go into 21? 21 divided by 4? No. Okay, 21 divided by 9? No. 21 divided by 16? No. And then obviously we can't do 25 because 25 is bigger than 21. So actually our final answer is just something that looks like this. Okay, so when this is like, what is the simplest form of each expression? This is really it. Like, even though we can break down the square root of 12 into 2 root 3, it still does not combine with 5 root 2, and that's okay. All right, let's take a look at number 4. Here we have the square root of 8 times the square root of 3. And then we can distribute the square root of 8 times 3. And this becomes the square root of 24 plus 3 root 8. Okay? We can totally break up the square root of 24 into the square root of 4 times 6. And we can also break up the number 8. So take a look at this. Plus 3 times 4 times 2. Okay? Now, look what happens here. This can become the square root of 4 times the square root of 6. Plus 3 times the square root of 4 times the square root of 2. The square root of 4 becomes 2. This square root of 4 becomes 2. The 3 stays out in front. The root 6 stays the same. The root 2 stays the same. And then this becomes 2 root 6 plus 6 root 2. And these do not combine. So actually this is the most simplified form of number 4. So even though 3 root 8 did not match the square root of 24, we could still break up the 3 root 8 into something that's simplified with a perfect square. Okay, let's take a look at the second page now. Okay. Now we're going to go ahead and take a look at some more distribution. We're going to multiply the square root of 3 by the square root of 12. We're going to multiply the square root of 3 by 4. Oops, I'm sorry, guys. When we do that, we end up getting the square root of 36 plus 4 root 3. Okay, the square root of 36 is 6 plus 4 root 3. And this is as simplified as this gets. All right, hang tight, guys. We're going to have to pause this video and we're going to have to switch it to a second one. We'll be right back. Thanks.